Torque converter's job is to transfer the power of the engine into an automatic transmission somewhat independently of the engine. Think of it as a fluid coupler. Transmission fluid inside the torque converter is centrifugally driven by a series of precisely made fins that are braced into the converter housing called the pump. At a given engine RPM, also known as stall speed, fluid is transferred to the opposite side of the converter and drives a turbine. As the engine's RPMs increase, the fluid transfer rate increases, putting more pressure on the turbine to accelerate the vehicle. The turbine is attached to the spline shaft that goes into the transmission.
A torque converter performs the same duties in an automatic that a clutch setup does in a manual, except there's no third pedal. At low RPMs, the engine is producing very little torque and there's very little fluid transfer happening, so keeping the car stopped at a stoplight is easy as light brake pressure, kind of like when you clutch a car when you're rolling to a stop.
Torque converters come in several different sizes based for their specific application. Now, not one torque converter will work for every setup. A torque converter is spec'd based off of the car, the engine, and the transmission combination.
In racing applications, the converter is designed to keep the engine in its power band and not fall below peak torque.
This converter is a race-style lockup type that has a few extra parts than a standard converter, but they all work the same way. Now, a cutaway like this gives you a great visual, and it's easier to understand. Plus, you don't have to cut one apart yourself. The impeller or pump and the billet lid are welded together so they turn at the same RPM as the engine. Now, the pump's fins are typically furnace braced at precise angles. The fins direct the fluid to the outer ring of the pump. That fluid then flows back across the outer section of fins on the turbine, which drives it. Then the fluid exits the turbine through these fins in the center and heads to the stator.
The stator is the brains of the converter and arguably the most important part. Its job is to multiply the torque from the engine. Fluid flows to the center of the stator, which also has angled fins. Inside the stator is a one-way clutch that allows the fluid to turn it in only one direction to reverse the fluid angle as it flows back to the pump, pushing the fluid faster, which drives the turbine harder to catch up with the engine's RPM. We'll dig deeper into converters a little later, so until then, stay fluid.